All right, welcome everybody. Today we are going to be working on notes 5.3, six trigonometric functions. That is correct. We said six. I know we are so used to the concept of SOHCAHTOA, where we only have three trig functions. Well, there's actually six that exist out there. So we're going to talk about the other three for the very first time. So last week we were reviewing sine, cosine, and tangent. Well, now today we're going to find out that there's some reciprocal identities that are related to sine, cosine, and tangent. Now, of course, just as we mentioned before, we are going to be working with right triangles because that's where trigonometry, the one which we're using right now, SOHCAHTOA, they require the use of right triangles. So just like last time, here's my angle. Yes, this is still considered my reference angle. So we'll need that eventually again. So there's my reference angle. But just like last time, look, we have our hypotenuse. That is the longest side of the right triangle. It doesn't touch the 90, of course. We also have the opposite side. This is the side that does not make any contact with our reference angle. And then, of course, we have the adjacent, and the adjacent side is the one that makes full contact with the reference angle and with the 90. Right? It's the only one that's between the two. So we're still going to need this concept of HOA, the hypotenuse, the opposite, and the adjacent. So how does this connect, right? Now, when you look at it, you're going to say, oh man, now we have to know six of these. Well, not really. Look carefully. When you're working with SOHCAHTOA, right? When we were working on it back in the day, we said sine is opposite over hypotenuse. Okay, so there's the SOH from our friend SOHCAHTOA. But then look at the connection. They're saying that sine is directly linked to this brand new trig function. Now it says CSC. That is short for cosecant. So cosecant is how we pronounce it. But then look at the fraction, and this is why we said they're connected to each other. Because if it's SOH, opposite over the height, well, this is height over the opposite. So if you notice, all we do is we flip the fraction over, also known as a reciprocal. But that's all we have to do is just flip the fraction. Same thing goes with cosine. We already know that when we're dealing with cosine, that's adjacent and hypotenuse. Well, it's the same rule that we learned before. We say CAH when we were writing down the name SOHCAHTOA, but now directly linked with cosine is this brand new trig function that has the initials SEC. Well, think about it. Look, this is sine. This was called cosine. Well, if this one's called cosecant and this one starts with SEC, well, then that's because this one is secant. And again, all we do is we flip the fraction over. It's all we have to do to get these brand new ones. And then finally, right, last one here, we have tangent. Well, we know tangent. According to the name SOHCAHTOA, that was the TOA because it's opposite over adjacent, just like the letters say. And if you look, related to tangent, well, it's COT. Now, again, look at the names. We have sine, and then there's cosine. There's secant, and then there's cosecant. Well, if there's tangent, well, there's only one thing that there can be here. COT is for cotangent. And cotangent, if you notice, is just adjacent over opposite. So that means all we had to do was flip it over one last time. That's exactly what's happening here. So we're still going to use the opposite, adjacent, hypotenuse. We're still doing all of that. But all we're going to do is flip the fraction. So when people say, oh man, this just got tougher. No, it didn't, because you're still just going to do SOHCAHTOA. You're still going to do those. And then when they ask you for the new ones, well, you just flip everything over. So it's not like you have to memorize this whole new thing. What you should work on is knowing who's related to who, right? Like sine is related to cosecant. Notice how the cousins, I like to call them the flip cousins right here, because all we do is flip them over. So these are the flip cousin because they're related to them. So the flip cousins, if you notice, again, we call it that because sine is related to cosecant. All you do is flip the fraction. Cosine is related to secant. All we do is flip the fraction. Tangent is related to cotangent. All we do is flip the fraction. One thing to remember is these relationships, these cousins, never start with the same letter. The first and biggest mistake people make is when I ask, hey, who's the reciprocal cousin or the flip cousin of sine? They'll say secant because they start with the same letter. That's wrong. So please be careful. That, and it's in your word wall. So you shouldn't be worried about making that mistake, hopefully. As long as you look at your word wall, look, they're already listed. Sine, cosecant. Cosine, secant. There's the relationship. And there's the flipping. So you have this. So again, no reason to get this wrong. Now, the only other thing that we want to mention that's here besides, hey, all we're going to do is flip, 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 flip. Great. The abbreviation OPP, ADJ, and height are often used to represent the side lengths of a right triangle. We've done that. Note that the ratios in the second row are reciprocal, so there is that magical math word there of the ratios of the first row. So what they're saying is, we don't just call them flip cousins. There's an official name for all of these. Because remember, reciprocal just means flip the fraction, which is what we already mentioned up on top, but here it is again. All we do is flip the fraction. These again are called the reciprocal identities. An identity in math is kind of another way of saying a formula. So notice, they're letting you know who's related to who here. To get cosecant, they're saying flip the sign. That's what 1 over means, flip it over. To get the secant, flip over the cosine. To get the cotangent, flip over the tangent. So this is yet another look for this type of problem. All right, so we're only going to do this page right now to finish it off, and then we'll be done at least for today for this part of the video. All right, so here we go. We're going to practice. But remember, in order for me to do this, I have to know all the sides. I have to know my adjacent, my opposite, and my hypotenuse. The reason I need to know all of those is, look at the directions. The directions say, evaluate the 6 trig functions of the angle. All right, well, I need to know everything. So first of all, here's theta. There's the angle. My 12, well, this side doesn't touch that reference angle. So there's the opposite. This side touches the angle and is between the angle and the 90. It's got to be the adjacent. And well, we already have the height right here. So we already know the hypotenuse. The only problem is we don't know what this number is. So we have to find it. Well, this is where you need to come in. You have to know your basic skills to say, hey, they gave me 2 sides. Well, if they give you 2 sides, there's only one thing you can use. Pythagorean theorem. We need that third side. So I could go like this. Something squared plus something squared equals something squared. We could definitely do that. All right, let's see. I don't know the hypotenuse, so I could call it h, or you could call it c, right? A squared, b squared, c squared. This side is 5. This side is 12. All right, let me work this out. 25 plus 144. Let me zoom into this now a little bit more. Here we go, nice and exaggerated. Is equal to the hypotenuse squared. 169 is equal to hypotenuse squared. So when I take my square root, I don't want to mess with this here. So the hypotenuse is equal to 13. And there it is. I now have all 3 sides. I've got the 5, the 12, and we now have the 13 for the hypotenuse. So now I'm ready. I can answer all 6. So yeah, last time you were only doing 3 of these, right? Back in geometry, last week you were only doing 3 of these. Well, now they want 6 of them. And it sounds worse than it really is. Again, if you already know your basics, and by that I mean your SOHCAHTOA stuff. Look, you don't have to memorize anything new. Sine, opposite over hypotenuse. So, ka, toa. There it is. So then, let me bring in the numbers. The O is 12. The H is 13. Done. Cosine. The A is 5. The H is 13. I'm just putting the numbers where they belong. The O is 12. The adjacent is 5. There it is, ready. And I'm done. But now that I know, hey, there's 3 more to do, it's not like I have to do anything else. I don't have to do more math. I just have to write it down. They're called the reciprocal cousins or the flip cousins. Cosecant is related to sine, then flip it over. My answer is 13 over 12. Done. Cosine is related to secant. So HA, that means 5 over 13 becomes 13 over 5. Done. And then O and A, 12 and 5. Well, then this is A and O. Then this is 5 and 12. And just like that, I have all 6. The real math was here. You trying to figure out what that third side is, because once you have it, you're just going to fill out SOHCAHTOA, and then you just start flipping over for these. That's why it's a little more writing, but the difficulty level hasn't really gone up. All right, let's try one more. Now, before I do this last one, I do want to mention one thing. We did Pythagorean theorem to solve for this missing side right here. Remember, as soon as you know that Pythagorean theorem is what you're going to apply to a problem, and again, that has to come from you making that recognition there. So here's what I used. Here's where I should have looked first. If you notice, I could have saved time. There was a 5, there was a 12, there's a 5, there's a 12. This list, this Pythagorean triple, is telling me that my answer was a 13. I would not have gone through all this work if I had looked at this list first. So please save some time. In fact, let's see if it works for this one. Evaluate the 6 trig functions, and let's see, the sides are 15 and 17, but here's what's important. Yeah, here's my angle. This is the height. So if your height isn't 17, this doesn't work. Well, there it is. Look at that. Pythagorean triple. The hypotenuse is 17. The leg is 15. And there it is. Without any work, I already found that this is an 8. Again, please look at this list, use your word wall, because when you have a Pythagorean triple like this one, which was 8, 15, 17 has to be the height, and it is, that's how we get that number 8. And we end up saving a lot of time for a problem like this. We save a lot of time when we can find a triple that works. Now, if it doesn't work, well, then that's when you do this whole Pythagorean theorem thing. When it doesn't work, that's when we go old school. All right, well, I have everything I need. I just have to label. We already know that's the H. This side has no contact with my reference angle. Then there's the opposite. Here's the reference angle and the 90. So there's the adjacent. Labeling is big. And now I'm ready to answer everything because I already have all my sides. So here we go. All right, just like we did last time. So, ka, toa. Now I'm just going to put the numbers where they belong. O is 15. H is 17. A is 8. H is 17 again. The O is 15. The A is 8. There. SOHCAHTOA, sine, cosine, and tangent have officially been answered. And remember, all we're doing is setting up fractions, nothing else today. Well, then here comes all the cousins, right? All the flip cousins. The reciprocal of sine is cosecant. Then flip over the O and the H. Flip it over, HA. Flip it over, AO now. See, all we're doing is flipping, which means when I write my answer, all right, flip it, 17 over 15. Flip it, 17 over 8. Flip it, 8 over 15. And just like that, we answer all 6 trig functions without a lot of extra work. I really just set up SOHCAHTOA, which is what I memorized, which leads me to do these, which are called the reciprocal, aka the flip cousin. All right, at this point, instead of doing any U tries, go straight to your classwork. Finish those last problems in your classwork, check your answers. Remember, you're turning that in, and then jump right into the homework. You have plenty of time in class to get all the classwork and the homework done. So there is no reason to have missing assignments so far. With that said, have a wonderful day, everybody.